Imagine a concept that you are expected to know from your physics review, and that concept led to an absolute revolution in medicine. Don't you think that that's going to come up rather frequently on the real exam? Yeah, it does. And the revolution I'm talking about, of course, is fiber optics. And the concept is very basic because we've reviewed it already. So first of all, the revolution in medicine. I'm so old that when I was doing my surgical training, a lot of my staff or teachers, professors, a lot of them had trained only using rigid endoscopy. And what that means is tubes made of metal, quite long, that are put in orifices of patients while they are not asleep. So just to say, we live in better times. Anyway, flexible endoscopy came out, of course, and that used fiber optic cables that are flexible and so not so painful and not as difficult in order to go through certain procedures. And in fact, many other procedures were created based on these fiber optics. So, because of the fiber optics, these cables, which are flexible and have these little glass tubes, an image can be transmitted to another side as long as these tubes are properly arranged. So in order to understand how this is possible, to transmit through corners and turns within the human body, to see something like, in this case, the inside of the bowel or the lumen of the bowel. In order to be able to do that, let's take a closer look at one fiber optic, and then we can understand the physics of what is happening. Okay, now we are looking at a single fiber. Here is the inner part of the fiber, or the core, and it has an index of refraction, N1. And here's the outer part of the fiber, which is called the cladding, and it has an index of refraction, N2. Now, light passes in one fiber, and because the light ray is beyond the critical angle, there is total internal reflection. So that's why light can enter at one end of the endoscope and then go all the way to the other end of the endoscope, where an image can be viewed either through looking through a viewfinder or looking at an image on a television screen or something like that. So the key part in terms of the physics, and you may want to pause to just consider your answer, is the core has an index of refraction N1 and the cladding, the outside, N2. My question to you is, which of the two is the higher index of refraction, N1 or N2? So consider your answer and then come back. Of course, just like the example that we did with water and air, where the light remained in the water because water has a greater index of refraction. Water is the more optically dense medium. Likewise, here the more optically dense medium is the core. That is why the light rays are retained in the core and are not able to go out. If it wasn't for the cladding, because all the fibers are together in the endoscope, if it wasn't for the cladding, then the light rays would be bouncing between fibers. But because of the cladding, the light rays are maintained within one fiber, and you have total internal reflection along the length, even though the endoscope changes directions and turns and curves and so on.